Hey everyone, welcome to my today's session. In today's session, we're going to continue our journey with Power BI new format. This format powered with the Git, which is the version control tools. We can really embrace an environment which multi-author can work together on the same data project. It's not only increase the transparency about your project, but most importantly, you have a buddy by your side to keep track of what has been changed. And also, we're going to go through a peer review process within the GitHub so everyone can have a proper approval process, and also we can make the production more efficient. So let's just get started. First, make sure you have the Power BI desktop installed and save your traditional pbix format into this new project format. Once you save that in a dedicated folder, you will receive 2 additional folders and also 2 additional files. And next is make sure that you have the Git installed on your PC. And next, you need the GitHub CLI installed as well. Make sure you have those 2 additional software installed. Then next step is open the PowerShell and move to the working directory. Let's just first do some basic checking, because if we're using any software, there's some unmentioned login has been created, so you need to make sure the configure things are correct. So let's just first check the Git settings. So with the Git setting, we're setting is the configure. With the config, we can check the user name, Benza, which is correct, and also we can check the config user email. So with this email and the username and email, we're okay that whenever I make a commit or do something within this local repository, it'll capture this name and this email address, which is fine. Second, we want to check the GitHub author login. So if you've done this first time, you can just say login. This will initiate a user-friendly prompt saying which you're going to use for that. So remember, these are 2 different command systems. This is for local repository setting. This is for your GitHub on right-hand side setting. So what I'm trying to do is locally in my PowerShell, in my PC, I want to set up a connection from this session to the cloud. So that's where it hits. So we just choose the first one. And second, we choose HTTP. Next, say authentication gateway with your yes. We're going to say yes. Next, we're going to use the browser login, which is okay. And then this is the code. If we hit enter again, you can see our web page has been refreshed. We're going to assign as this one. And then this is the pairing code. I got it over here. So you can copy that, paste over here. So paste, we can continue. Then we just authenticate the GitHub. This session has been done. Let's go back to here. You can see there's additional lines being running, and then say already set up. You can also check this by using a different command. Instead of the gh authenticate, you can use status. Since I've done 2 logins, so it will track one author, developer A, second author, developer B, but this one is false, which means hasn't been activated. Right now, I'm activating this one only, so that's okay. So 2 settings. Git setting we have checking is fine. GitHub setting checking is also fine. So let's move to that. So right now we have done is we have going up. We have checked 2 settings. Next, we're going to check the Git status. With the Git status, it's set as fatal. There's no anything tracking. So pretty simple. We can just initiate that. With this, there will be an additional hidden file being enabled in the working directory. If we're going back to folder, click view, show, unhidden, you can see this one is here. So that's created by this Git initiate. So since we don't need that visible, we can uncheck that. Now we're going back to our PowerShell session. So within this session, what we're going to do next is just add every file. So if you check Git status for now, the red one means untracked. So we need to add them into the tracking. To add a space, full stop. So add everything into that, and then I say Git status. Now you'll see many green files. The reason you have so many because the folders under each of the folder, they have files under each of the folder. That's why it's like this way. So let's just make it first commit. So the first commit will leave a message saying the first commit. We've done the first commit. We can check the Git status. Our working directory is okay. Every change has been tracked and commit. And then if we check the Git log with 1 line, you can see that's the line saying 3 informations. First is the commit code, which is a hash key or identifier, whatever you call it. It's ID. Head is important because head is telling you where you are at as of now with this session, because sometimes you're backtracked to like say a historical point. So right now the time point is very, very up to date. I'm under the master branch. This is the branch, which is a production branch. With this commit, I have the message say first commit. Okay, now I have done the local one for the very first stable version. I like to properly register this version. So use a tag and -a. I leave this as version 1.0. Then I leave a message saying stable version 0.0. Now if we git log again, you can see additional information has been revealed for the tag. This is what we'll talk about this, how to use that in the GitHub later. So once we have done this, next step is we're gonna push this to the cloud. But before we push, going back to the cloud, refresh this page, nothing yet happened because we haven't created anything. So let's back to the PowerShell session. Going here, we're gonna use a different command, use the GitHub command. This time, I'm gonna create a repository, so repo create. You can simply stop your code over here because there's an additional command to come up on the screen which help you to finish the process of creating a repo in the cloud. We just hit enter. It will say, would you like to, 3 options, create new. No, we don't want create new. We want to push existing to the cloud one and create new. So that's the last option, push an existing local repo to the GitHub. Hit enter, and then it asks, okay, what kind of file you want to add? Like everything we have done before, we use the full stop to represent everything, or if you don't type anything, the full stop in the bracket will be picked, so we can remove that. Just hit enter. You can see the blue one means the option that I preferred. This is the same thing. If I don't hit anything, type anything, I just hit enter. This one will be the repo for the remote name. Hit enter again. So that's the name be confirmed. Description, we just leave a demo. Next is the visibility. What the visibility tells us is that, do you want to make your cloud repository open to everyone or just private? Private, we want to make it private. So the second one, okay, now has been created. So this is the chance that we can go back to here as the author A, developer A, refresh the page. You can see this has been created just now is because the line over here. And right now this is empty. There's an additional screen that we need to go through. Let's go back to PowerShell. The first add a remote. So remote is actually a special term in the Git environment. Remote represents a repository, not your local one, but have a connection with your local one. So we want add a remote, right? We say yes. Once we add, it'll say, okay, what kind of name you want to call that? Abbreviation. This time we're going to keep it as origin. So origin is the one. Now we have added a remote to this one. If we refresh that, still there's nothing because the local and also the cloud, right now the difference is the local one has your first commit, also the tag. Second, the cloud one doesn't have that. Cloud one doesn't just have a repository which is totally empty. So that's why the message here saying, would you like to push the command from the local to the cloud? I say yes. Now it's been pushing everything to the cloud. Now let's back to the browser, refresh. You can see our first commit has been done just 4 minutes ago. That's the time we get the commit, not the time we push to the cloud, right? Okay, so now it's a time to push another thing. Remember the tag thing? We have this tag 1.0. Tag thing is mainly been reviewed from the cloud by this release. Right now it has nothing. So what we can do is you can say git push, just double hyphen, and then tag. Okay, now we have pushed 1.0 to the cloud. If we refresh the page, now you can see that in the release, I have one tag. If we hit over here, that's our 1.0. If we open that, it will have the message that we have stable version 1.0, right? So that's the release that we have done for one of the commit. Let's back to the code place. So now the local and also the remote, they are exactly the same. It has one branch locally. You can check that git branch. Yes, in the cloud, I also have branch, which is the master as well. And if I want to check the connection between the local and the remote, I can use git remote. So first, this will review the remote name. It's called origin. Second, we can use the same command with additional -v to review the actual URL of the remote, which is the origin. So everything has been set up properly. So this is the first version that we push into the cloud. Let's just get back to this repo folder. Let's also heading back. Now let's just say this one has been published into into the cloud. Developer A is very happy with this. Everyone is happy with the stable version 1. After a few days, developer A receive another request to what? To develop additional things on top of the master branch, which means he will develop something on his own branch. For example, a new feature for a new page. This way, he is not using his own PC. He's using some new PC. New PC, there's nothing else. So what he need to do is, first, what he can do is going back to here. So first thing he need to check is actually the URL of the cloud one. That's the URL. We can just copy. Let's just say right now under this folder, that's where the developer A standing is. So he first want to clone a repository. The address is this one. We'll call that as a developer A. Hit enter. So what this will do is this will create a new folder on his new PC with the repository name or the folder name developer A. Under this A, it has all the components that he need to develop. Because this one is already linked to that. We can check that with the git remote. Let's first get into this folder developer A, and then we just check the git log first. Same as whatever we have. Now you can see this git log versus the previous one we have. It has more information. For this one, you can see in the middle, we only have 2 components. But right now in the middle, we have 3 components. So this one stays the same. This part stays the same. This one is different. Those 2 are telling us, okay, you are able to figure out the header for your local repository, which is this developer A, but also the header for the cloud repository is called the origin and under the master as well. So that's telling you additional information. You can confirm that with the remote. The remote is called origin, and the remote, the URL is this one, which is exactly as what we expected. So now developer A won't do something additional, new page, right? He has cloned the repository under the developer A folder. Now he can open this file. Okay, now we have opened the file as developer A. Remember, he needs to develop a new page. Let's explore the things first. New page, we're gonna call it a filter propagation. Here you already have that. Just need to drag a table to explore that. We want to explore the filter propagation feature, which we're gonna leverage some tables. For example, we want to understand how the filter propagation works among 2 tables, order table and the custom table. Custom table is the one side of the relationship. Per the definition of filter propagation saying, if you filter put on the one side, it will propagate to the many side, which means if you pick a customer from the customer table, the order table can also be filtered down or draw down to that particular customer. So we have done this. We can back to the all tabs and then going back to here, add a new page. We call it filter propagation. With this page, I want to add header filter propagation. With this ready, I'm gonna make this 40 in size and drag up. 2 table, I need order ID and customer ID. And for the customer table, I want the customer ID, which means if we drag this over here, if I pick a customer, the many side table will be filtered. If I pick a customer, the many sided table will be filtered. So that's basically the definition of filter propagation in the Power BI semantic model. We're okay with that. Let's back to the normal. Going to the home page, save. The reason I'm going to the home page is that whenever you develop new things, you need to make sure first the new thing that you develop appear in the right spot, which means I have this filter propagation created and it has the right amount of information, which is correct. 1 text box, 2 tables. Second, you want to make sure the thing that you haven't been touched or have no intention to touch stays the same. So you know that whenever you save this pbip or any file, the current active tab matters. So if I stay my mouse over here, make this active and save, it will capture this moment, which I don't want because I want everyone open the file as the fresh new and just stay with the main page, which is the home page. That's why I navigate back to the sales executive summary and keep it saved that. So this is the moment I want to save. I save that. Once we save, we can close this file. Since we have done some changes for this developer A environment, right? But if we check the Git branch, locally I have a master. If I check the everything, locally I have a master. In the cloud, I have a master as well, but I do need a local branch which is different from the master. Master is production. We have mentioned that. There's no doubt about that. Since in the new feature, before task, I don't want to touch the master. So you want to create a new branch. We use git branch over here. And then we just create that feature branch. This feature branch, you can make it even better by including something, but now just keep it as feature. We're okay with that. Once we have that, we can check the git branch. Again, nothing, but you can see green one means that our current branch, this one hasn't been checked out yet. So we can check git check out, we say the feature. This will move our current tracking things into a different branch. If we check the git branch again, now the green one highlight means that we're currently under the feature branch, which is a branch for this new feature. Specifically is done by developer A, right? Okay, since this has been done, our next step is git status. Under the git status has said this is many things has been changed. Reason is been that because I have opened the pbip as the developer A, add additional page with several information on that page, which makes sense. So we're gonna say git add. Once we add it, next step is gonna be git commit -m with a message saying new page, filter propagation. Okay with that, commit done. Say git log, one line. So now you have a clear picture of what is going on. So the top is the commit that we just did under the feature branch. So that's why our head is here. We check it out a different branch. The head will move away from the previous one. The bottom one is the initial git commit that has been done through a different folders, through these folders. And we upload this to the cloud, and then developer A on his new PC clone that repository. That's why it has this one, right? So now if we can check, we can get git log. We can use a graph to actually check the things. Graph. Let's review additional information. There's a line over here. It says that original commit was happened on this point and with this additional information. Remember I said the commit key can be the first 7 letters or the whole thing. That's the for path or for code of this commit. The second one is this one, and this also name was defined by the git config command. Okay, now we're okay with the thing that we have done in the feature branch. Now we need to push this to the cloud. So currently I want to check again our current branch. This feature is okay, so I'm gonna push this to the remote. The remote is called origin, right? I'm gonna push this feature, right? We hit okay. Now the new branch has been created. You can see over here, feature branch has been just released. If we refresh this, we'll check that. Currently, I'm under the master branch in the cloud. Now we have a new feature branch. Feature branch has different commands, saying new pages, right? So now if I check the git branch -r, you'll see additional informations. So under this one, we have this feature master all in the cloud, right? So you can see git branch, or this will review everything. Green, same, likewise, my current branch. This one in the white color means current repository. I have another master branch. All the red point to the remote one. So the head currently is under the master, and also there's a feature branch and also master branch. So that's everything that we have done. Since developer A has done his bit, he wants developer B to review the code. What happened is, for this repository, we want to add additional collaborator, just add these people. So that's the one we want to add. Pick this one, add. So right now I've added this by Firefly, which is another of myself, which is developer B, to collaborate on this repository. If I go into the message section, I can see this new message. I can participate by accept this invitation. Now I can see the repository, but still this is too general because as a developer B, I don't know what to do, right? So do you want me to do on what kind of things? And it's not specific the thing, right? So basically what will happen is developer A has developed a feature branch. He wants to developer B, which is this one, to review the branch of the feature. If feature is okay, we want to merge the feature back to the master, which is production, right? So let's head back to the PowerShell. The developer A has done his bit. Developer B's point is trying to review that. So we need to communicate to the developer B. You can through chats, but a more programmable way is create a pull request. In order to create a pull request, you need to use the GitHub command, which is ghash pull request. Right now, you can list that first, since there's nothing we created previously. So we're going to use the pull request to create. With this command, we can do additional things. For example, we're going to create, we want to create a pull request with the title. The title going to be new feature review. And the body is going to be the new page. Page is going to be called future propagation. And I want to add a reviewer. I know the reviewer, we need to use a GitHub username. The developer B, his name is by Firefly, so we can include that in the session bio Firefly. Okay, we hit enter. What this will do is it will create a pull request for the branch feature and also add the developer B saying, hey, please review this. So let's refresh this. Now you can see there's a pull request. We refresh the developer A, also has a pull request. So this pull request specifically, I'm asking developer B to review that, right? You can see this pull request was requested by firexcel, which is developer A. Now the developer B can go into this pull request, review the commit we have done online to see what has been changed. So this tells us the JSON file, what has been changed. So over here, we don't touch the width, but we remove the tab order. You can see the tab order has been removed. So order red means been removed, gray means added. But there's additional things which is under our expectation. First, we have a filter propagation page, right? Second, we have a table, and we have another text box, and also additional another table. Over the bottom is additional tracking changes, active pages, right? So everything. So if we're okay with this, we can just approve by here. But if you're not sure, we want to visually check in that, right? So even the code, you're okay with that, you still want to check into the actual looking. So let's heading back to this folder. So developer A, we have done. Let's switch our mind. We're now developer B. Think about this folder is under the developer B. He doesn't have this too, but how he gonna review the code? So we kind of need to download the pull request from the cloud into the developer B's local repo. So what we do is pretend we're opening this developer B, and we're gonna cd back to the folder, which is repo over here. And then we're gonna make sure the developer B has the URL of the code of the repo. So we copy that. And then going back to the folder and this one, what we're going to do is use a clone. With this clone, I can include the repository dedicated address. I'm going to call this developer B, right? What this will do is it will create a new folder. The new folder has all the information that been pulled from the cloud. And most importantly, if we use pull request list, let's head back to the developer B's folder and then use a pull request list. Most importantly, it tells us there's a pull request in this cloned repository and number is 1. If we're going back to here, if we check here, so that's the number 1. So it assigns a unique number to that pull request for developer B. So right now developer B can do is he can just directly GitHub pull request checkout. We're going to check out in the number 1, hit enter. Now you can see developer has switched the branch. If we check the Git branch, under the developer B's folder, he has 2 branch master. He doesn't care. He only cares about the feature branch developed by developer A. So right now with this code, I have switched my dedicated branch to review the code, right? Once I switched, I can go back to the developer B's folder and open this file. Developer B has opened the file. And he's actually going to the filter propagation to check, okay, everything seems like nicely being aligned and everything's okay. He's happy with this change, right? New page, nothing changed. Visually, he's okay with that. Minimize this. Since developer B is checking the code online and also checking the visual locally on his Power BI desktop, he's okay with that. Let's pretend we are developer B going back to the GitHub, developer B, right? We just need to go into pull request and open this pull request. We can review this, right? So that's the one commit we reviewed and the file change is 21. We're okay with that. So we can add a review. So let's review this again. So the code, all of this is okay, it's very safe, and the newly added things is also great. So we can leave this as approved with a message saying, hold on, say, nice work. We're gonna add our another developer A, leave this submit. Okay, now let's change our perspective. Going back to this, refresh that. Now additional saying it's open by developer A and also right now is approved. So going back to here, you can see we developer A commit and create a pull request for developer B. Developer B going back to here saying everything's checked, nice work, developer A. Now is a chance to say what do we do with this feature branch? So in the normal development life cycle of feature branch, the life is short. Once the feature is fully developed and also merged to the master, I mean, every change has been applied from the feature to the master, the feature will be gone. Be gone means that we remove that totally. We don't create additional hassles. So, but before that, we need to make sure the master is up to date. So what we do is do a merge. What merge does is, right now, if we rerun that, git log graph and decorate. Under this repository, we have two things happen. This one is the master. So master stays a little bit behind. The things have been developed only existing in the feature. So we need to bring this back to the master, which means we will move the head of the master from here to here. So that's why we need to merge these two, since there's no conflict, because this one is totally based on this and there's no additional development on the master. So the feature is totally beyond the master. So when we could pull this, we actually gonna do a merge, which is a fast forward merge. So what we can do is merge pull request, leave everything as normal, confirm merge. Okay, once we confirm, you can see this two has been updated. So here, if we're going back to this GitHub, what we do is, if we check anything, nothing has happened. This is the exact same as previously, like we have done nothing. But this cloud has been changed. Why my local now changed? Like I mentioned before, we only have a connection metadata about your local and also the remote. If you want to sync them together, you need to tell the system to do that. So that's why we have this git pull. What git pull does is it will sense everything from the remote here, the change, and make sure the local is up to date. So we can git pull and hit OK. Now if you check the git log again, you can see the difference between these two. I mean, this line and this line is that here I have two red lines. Different commit, they register what happened in the cloud. Now we can check out to another branch, which is the main master. Then we do the git checkout master. We do another git pull. Okay, now our master has been done to synchronize the cloud. You can check the git log again. Now you can see our master has been moved from the bottom to the top. And in the meantime, we also have a feature branch, but this is probably hard to look. We can modify the code to include the graph and also decorate that. Okay, so this is what happens. The first initial commit has been done in the developer A with the tag version 1.0, and then developer A somehow create a feature branch for the new page. You can see this kind of depart from the main line, and then after this, developer A create a pull request for the developer B. Developer B review the code, provide a feedback saying that's okay. So developer A again merge the feature branch into the main, which is the master, and make an additional command. This is where I make the master over here. The head is the master, everything's up to date. The only thing, the noise right now is the feature branch. That's why if we're going back to the repository, check the pull request, there's one closed. If we open that, it has a system message say you're all set, the feature branch can be safely deleted because everything in the feature has been reviewed and saved in the master, so we can delete the branch. Since this has been deleted from the perspective of the developer B, you can see the feature branch is gone, but this deletion won't reflect back over here. So if you rerun the command, everything will stay the same. Let's check our current branch. So we're on the master, so we need to manually delete that. So branch, D, and feature. So now we have done, if we rerun the log, it will review the original tree, but if you run the git log one line, you can see there's nothing over here. If we check the git branch, Again, we only have the master. If we check all, that's everything we have. But also there's a memory of the cloud one. Cloud one still have the feature. We need to sync that. So we need to git fetch and use the pruner. This will make sure our cloud record has been up to date in the local one. So git branch all. So now everything's been up to date. Now just rerun the git graph decorate, right? This is still review the full picture of everything. So now we have done the changes and everything in the master. Let's just check out as a developer C, not CD. We want to confirm the change has been applied into that run, right? So what we do is git clone. Git clone, remember the address that we have over here is copy that anyone. And let's just say developer C. Once I clone, we get into the developer C folder. And then we can just invoke item. The item is actually, let's list that first. List. So this is the one that I need. So invoke item. Make sure the previous one we close that, right? This invoke item gonna be this one. Hit enter. Now it will open the Power BI again as another independent developer. As a developer C, you can see the new pages here. Everything's here. So now developer C has opened that. He can actually do additional peer review if it's required. So with this settings, you can really embrace the new mechanism or the workflow of Power BI development. Most likely sometimes, when you as a solo developer, you may have, like say, less capacity to see what's changed, what if the intention change has been made and also the unintentional change stays the same. That's why it's very important to do peer review. With this version control system, what you can not only do is just have things tracked in one place and with the Git keep track the history, but also people can review the change by just looking at the code or just open the file. So they have the flexibility to review your code. So that's wrap up for today. And I hope you enjoyed this kind of session. We're going to continue in the next episode. We're going to talk about the previously unsolved about the SQL. And stay tuned and see you guys in the next one.